Hello friend, welcome to the channel DC Math. In this channel, I shall try to upload some basic information about mathematics that I have learned. In this video, we are going to discuss about the definition of injective mapping and one or two examples of injective mapping. Let us read first. A mapping F from A to B is said to be injective or one-to-one if for each pair of distinct elements of A, their F images are distinct. In other terms, we are seeing that F from A to B, a mapping F from A to B is injective if x1 not equal to x2 in A implies fx1 not equal to fx2 in B. This means that if we take any two arbitrary distinct elements from the domain set A, and if their images in the codomain set B, which are fx1 and fx2 respectively, are also distinct, that is x1 not equal to x2 implies fx1 is not equal to fx2, then in other words, we can say that if we take any element from the codomain set B, either it has no preimage in A or it has preimage in A. But if any element taken from B has any preimage in A, then it must have at most one preimage. This is the most important term for any injective mapping. In this case, each element of B has at most one preimage in A. This is the most important term to understand. Okay, let us consider A is equal to Z, that is domain is equal to the set of all integers Z, and codomain B is also the set of all integers which is denoted by Z here. Okay, we are defining a mapping F from A to B where fx is equal to x plus 1, where x belongs to A. Okay, we are considering any two arbitrary elements x1 and x2 from the domain Z where x1 is not equal to x2. Therefore, x1 plus 1 is also not equal to x2 plus 1, and this is implying that fx1 is not equal to fx2. We are writing this by the definition of f, which is fx is equal to x plus 1. That is why x plus 1 is equal to fx1 and x2 plus 1 is equal to fx2. Therefore, we are getting that for any two arbitrary elements taken from the domain Z, we are getting that their images in B are also distinct. Since this result is true for any two arbitrary elements from the domain Z, therefore we can say that F is injective. Similarly, we can set many other examples like fx with the same domain and codomain, like fx is equal to x plus 3, fx is equal to x minus 100, etc., etc. Also, we can form many other examples of injective mapping. I shall try to upload some other examples of injective mapping in some videos later. Now I am going to the other example, which is, here we are also considering that the domain is the set of all integers z and codomain B is also z. We are defining f by fx is equal to x square. Now 4 is an integer, therefore it belongs to the codomain set z. Now we see that if x is equal to 2, then x square is equal to 4. Also if x is equal to minus 2, then also f of minus 2 is equal to also 4. Therefore we are seeing that in this mapping, in this particular mapping, f2 is equal to 4 and f minus 2 is equal to also 4. Therefore 4 has two pre-images. 4 has two pre-images. Therefore by the very basic definition of injective mapping, we can say that fx is equal to x square is not a injective mapping. Okay. Similarly, we can show many other examples of any injective mapping. Later, I shall try to discuss some more examples and some more characteristics of injective mapping in some videos. Thanks a lot. If my videos are helpful to you, subscribe my channel and like my videos.